going to be building a 6 degree of freedom CAD mouse, Spacemouse, using Hall effect sensors. These Hall effect sensors, they're very small 49E linear Hall effect sensors, very cheap as well. This bag of 40 cost me around about £10. Because they're so small and my eyesight isn't quite as good as it used to be, I will be connecting them using these servo connectors. As you see, they plug into the servo socket very nicely, and the only problem is that the wiring is incorrect for them. It's got the power lead in the middle for the servo, whereas with the curved side up, or with the angled side up, going from left to right, we've got the power coming in, the ground signal, and the sensor output on the right hand side here. So what I'm going to do is I'm going to swap these two leads over by just gently lifting the tabs here and sliding out the pins. I'm going to be assembling the CAD mouse using a dark PLA, which isn't conducive to a good viewing angle. So I've got this, which is my final prototype that I've robbed of its Arduino Pro Micro and magnets and sensors, and it's easier to see what is going on in this. We've got 5 different plates here. The bottom one is the Arduino plate, holds the Arduino, and that's all. The next one is what I call the bolt plate. It holds this 4mm M4 40mm long bolt that holds everything together, and it also has the bottom springs hooked into it. Next is the sensor plate, then the magnet plate, and finally the wire plate or wire holder, which just supports the upper springs here. So let's get started. This is the Arduino plate in the final model. It simply holds the Arduino Pro Micro in like that, and there's a hole in the side where you can slide in a bit of filament just to hold the board in place, and there's a hole on the other side. It should line up like that. I'm going to solder the wires directly onto the Pro Micro to save a bit of room, and I will do that now. Right, the wiring is done. Quite a lot of wires here. I've kept the wires as short as possible, but there is space behind the Arduino for any excess wires. I have labelled each of the sensors so I know which analog pin it goes to. And you'll notice I've also got switches. The teaching tech code had 3 reports in it. First one was the report that says what the linear movement is in the 3 axes. Second report was the rotation across the 3 axes, and the fourth report was the status of up to 24 switches and buttons. So I've added 3 buttons to this because I've got space for 3, and once we've got things connected up, we'll see what happens. The next thing we need to add to this is the bolt plate. It takes the M4 bolt and an M4 nut. Sorry, I'm doing this off camera. Didn't mean to. There we are. And just get a screwdriver, tighten that up a bit. And that. I think I'll put the switches in place first and then add the bolt plate. Right, that's the bolt plate on. Held on by M3 by 20mm bolts. I'm going to place another bolt on it because this will act as a spacer between the bolt plate and the sensor plate. I'm sorry you're not actually seeing what I'm doing for most of this because it's easier for me to work out of the lens of the camera. I hold it closer to my body and then it's not in shot at all, which is why this is jumping around a lot. There we are. I'm putting them right down at the bottom because it'll be easier later on when I'm hooking springs up through. Before I go any further, I'm going to take some of my piano wires. I have cut the piano wire into lengths of about 8mm. It is 8 pieces by 8mm. 1mm thick piano wire and 4 pieces by 15mm. And these will be holding on the springs. Another bit in there. So take the spring, put it in the slot, take this and push it in. That should hold the spring in place. Just like that. And then I do it for all 4 and then I'll mount the sensor plate. That's the sensor plate mounted. Took longer than I anticipated. Some of the sensors are quite loose, so I think I'm going to put a little dab of contact adhesive in the slot and then push them home and make sure that they can't come out again. Contact adhesive is quite good because it dissolves in acetone very easily and means I can move the sensors to a different design if I so desire later in the future. But the thing to do now is download the software, set the debug level to 1 so that I get the raw readings from the sensors, make sure that they're all working, and then test the magnets to see which ones cause the numbers to go down. According to the data sheets, running at 5 volts, the sensors should give a similar swing above and below the midpoint. So it wouldn't matter which direction magnets were inserted, but I find that you get a bigger swing with the North Pole pointing towards the sensors and the values going down. So that's what I'm doing now. With the magnets glued in, it's now time for the heat press inserts. These are 4mm deep and 3. Just need to heat up and then push in. Try and keep everything vertical. There it goes. Perfect. Next one. Just a wee bit awkward. Perfect. Now these. Had to rush off and change the design of the cover as I realised that the holes for the brass inserts were too large. So while that is sorting itself out, I will mount this now. The magnet plate goes over, obviously. We have these 15mm wire retention, screw retention things. Spring, should I say, retention. So we want to grab the springs from underneath. Carefully bring them up. Place the spring in the gap and push this across. Now I just have to do that for the others. The lower the sensor board is, the less tensions on the spring and the easier it is to do it. Right. Now we've got 4 remaining springs which we need to hook onto this. Not. It's got to be round the wire. Like that. And I'll just pause the video while I do the rest. With the springs in place, we can put another M4 nut onto the screw. We've got this wire plate which goes on top, and taking the remaining 8mm wires, piano wire, they should go in the slot, and then the springs lift over the wires. This is awkward because it's under more tension, but hopefully that's how you do it. And I know I'm going to get frustrated before I've got them all in place, because any time I've done it in the past and the tests, the wires have gone everywhere, just like that. It seems to be in place. It is awkward, but you get the idea. With all the springs in place, we can then tension it. Increase the tension by lifting it up and rotating the M4 nut so that we're holding the plate further away from the sensor plate, the magnet plate away from the sensor plate. I want it a wee bit more than it is. Something like that. And then we can adjust the height of the sensor plate so we're 5 or 6 millimeters away from the magnet plate. These adjustments mean that if we don't get correct readings or good enough readings, we can adjust things, maybe make the magnets closer to the plate or further away. We'll start with that. Screw these down. This part is optional. There's a washer, like the washer that goes over the top, and an M4 nut tightens it down. It can be used for just centralizing the magnets over the sensors and just holding everything in place. Before continuing any further, it's a good idea to plug this into the computer, set the code to debug level 2, and just verify that when you push down you get increased values in all of the sensors, and when you pull up you get decreased values. Once you've got that, you can then proceed by putting on the case. That's what we're going. You want to adjust the position of the top wire holder such that the magnet plate is in position, so when the knob is attached it clears the case and has sufficient movement. So we'll now start assembling it into its final position. This is the base, and it is basically hollow, designed to hold some weighted material that won't interfere with the magnets. I was thinking we could fill it with cement, epoxy resin, modelling clay. I've got some RC model weights for adjusting the centre of gravity. I might use those, but for the meantime I'm just going to put the plate on. It is entirely optional because the base of this is flat and can be used directly. So I'll put this on with M3 by 6mm bolts. I'm just going to use 2 here for the meantime. And we can put the knob on. I'm using M3 by 8. I must thank CAD Jungle for the model for this knob. It comes from a tutorial on how to model CAD mice. Link will be in the description. Press that in. Now we put the top on, align it. Oops, I forgot to put the buttons in. Buttons just fit in with the thick side of the button downwards. that, and then I'm going to put M3x6 in to hold it in place. Just hope if I use the right size Allen key. There we are. And again, I'll just put 2 in for the meantime. There we are. So this is our CAD mouse. We just put the cap on, and there we go. We've got the backwards and forward movement, the up and down movement, tilt to side, and a rotation.